Everybody, today we are discussing the next topic in supramolecular chemistry, that is the crystal engineering. In our childhood days, we have prepared the different shapes by using the building blocks, and we can make the different shapes like robot and house, tree, and bridges by using simple building block. Similarly, we can prepare the different structures by using the building block in chemistry also. That is we known as crystal engineering. So the crystal engineering is the design and synthesis of the molecular solid state structures with desired property based on understanding and use of intermolecular interactions. So there are the two different strategy for crystal engineering, which is based upon hydrogen bonding and coordination bonding. So the crystal engineering deal with crystals which are extended and ordered supramolecular assemblies of the millions of the molecule. By the analogy of the retrosynthetic approach in organic synthesis, we can also use the supramolecular synthons to describe the building block in supramolecular chemistry. And in retrosynthetic analysis, as we discussed in organic chemistry chapter, we will get a target molecule, and by cutting this target molecule, we will get a subunit, or we will get a starting material that we call it as synthons, and by combining this synthons we will get the target molecule. So similarly, we can use the supramolecular synthons to describe the building block in supramolecular chemistry. So what is the role of the hydrogen in crystal engineering and molecular recognition in supramolecular chemistry? So the many of the properties of the molecular material are did, are formed by the manner in which the molecule are ordered in the solid state. So if we have the ability to control this ordering, would afford the control over their property. So the if you are understanding of the intermolecular interactions in the context of the crystal packing and in the utilization of such a understanding in the design of the new solids with desired physical and chemical property. So the intermolecular interaction in organic solids are very weak. If you are inserting a functional group, forms an interaction with other group, but its exact behavior during crystallization depend upon the nature and position of all the other functional group in the molecule. So in supramolecular chemistry, we have to count a hydrocarbon residue as a functional group. Therefore, the crystal structure are not related to molecular structure in simple way, but it is depending upon the interaction which is present in the molecule. So if you know the structure of the subunit, the molecule express the different structures depending upon the interactive force which is exist in the molecule. So in summary, the crystal engineering involves a building up of the supramolecular entity with an intermolecular interactions.